Welcome to the @SQA webinar for AI for testers. This is partly a little bit of an introduction to AI in general and also an introduction to the @SQA micro-credentials for AI. I'm Judy McKay and I'll be your presenter. I think one of our big concerns right now as testers is what do we need to know? Because everyone's talking AI. It's AI everything. AI is going to replace all testers. AI is going to replace all developers. AI is going to be the most wonderful thing ever. But realistically, what do we need to know? What do we need to understand about AI as testers? There's four basic areas I think we need to discuss. One is, what is AI? What do the terms mean? Because it's really a bunch of new terminology, neural networks and large language models. And, you think, I don't know what any of those things mean. So one thing is just to get familiar with the terminology so we don't sit in meetings going, what? Because that's embarrassing. And then the next part of that is, well, how much do we need to know? Because quite frankly, I don't know about you, but I'm not going to be designing a neural network. I'm not going to be writing the algorithms. I'm not going to do that. But from a standpoint of testing it, what do I need to understand about how it works so that I know what to test and what to target? So that brings us to what should we test, which is closely aligned to what can we test? Because realistically, we're not going to be able to test everything, right? We've always been in that situation. But with AI, how deep are you going to go? Are you actually going to test the neural network itself? And does that even make sense? Is that even the right use of our capabilities? We need to understand what the expectation is for testing. How good does it have to be? And at what point in time does it have to be good? And we need to understand that the quality criteria have changed. There are different quality criteria for AI. And when we talk about AI, we're actually talking about AI-based systems. So it's not AI itself, it's a system that is using AI or is based upon AI. So those terms are kind of thrown around interchangeably, AI itself or an AI-based system or an AI system, all meaning basically the same thing, at least in this presentation. Next thing we need to think about is, how do we test it? Great, we can know what to test, but then how do we do it? Are there new techniques? Yes, there are. There are new techniques that we can use. And what about test automation? How does that fit in with this? And that leads us into our next thing, which is, how can we use AI to help us test? Can we use it to build tests? Can we use it to execute tests? What about test automation? Can it generate it? Can it run it? Can it fix it when it breaks? So we're going to look at all four of these areas in the upcoming AI micro-credentials, but I want to touch on these a bit today. So one thing we have to remember as testers, and this has always been true, but we cannot risk falling behind. We have to continuously learn and adapt. We have to understand the changing technologies because likely they're here to stay. And I think with AI, this is one we can't dismiss. This is one that's here to stay. We need to embrace the buzz, meaning that we can't poo-poo it. We can't say, stupid AI. Come on, who cares? Neural networks, who cares? We need to kind of get on board here. We need to understand what the words mean. We need to understand how it can be used and how it will be used. And quite frankly, this is such an emerging field. Pretty much anything I say is going to be outdated as soon as I say it. But for now, at least, what do we know about it and how can we use it? We need to know the facts and separate those from all of the voluminous information about how wonderful AI is and how it's going to change the world. And it may, but for right now, we need to understand how to test systems that have AI in them. The goal here is to keep a test-centric viewpoint because it's really easy to get bogged down in the technical aspects of AI, and it is really technical. And we don't really need to do that. So we don't need to be afraid of it. We need to understand it, and we need to understand what we need to understand as testers, not what we would need to understand if we were actually building it or if we were data analysts. We don't need to know that. We need to understand what we need to know as testers and accept the opportunity. It is an opportunity. There's going to be some real changes in our industry as a result of this. There's going to be some really cool tools coming out, and I think that's going to save us a lot of the grunt work that we all hate doing. But we need to be able to understand the good and the bad. Great that we have tools that can write code. How good's the code? Because if you're going to spend more time fixing the code than you would have spent writing it originally, not really that much help. The thing to remember too with AI is it's so quickly evolving right now that things that may not work really well today might be great tomorrow. So we always want to stay in tune and keep current on what's going on. And this is one thing that you can do with listening to webinars, taking micro-credentials, keeping your education up to date. So there's going to be 4 at SQA sponsored micro-credentials. First one is an introduction for testers, talks about the terminology, how AI works. The second one is what to test, talking about the risks with AI and the quality characteristics that we need to be sure that we cover in testing. Identifying risks is particularly tricky with AI because a lot of people assume that it's just going to work correctly. And I think we have a lot of proof that that's not true. But pointing out these risks is not necessarily going to make you popular, but it certainly is something that we have to do as testers because we have to talk about how we can possibly help mitigate those risks with testing. We can talk about how to test, which is the different tools, the techniques, the ways that we can go about testing AI that are different from the way that we would test regular software or traditional software. And we'll talk about using AI to test, how we can use AI-driven testing, how we can use it with automation, how it can help us do things that are either difficult to do now or time-consuming to do now, or stuff that we just flat out hate doing. That's the summary of the 4 AI micro-credentials that SQA is offering. They're each partitioned to cover a specific area, but should always do the introduction first because that gets through all of the terminology and all of the basis that you need to know. So maybe thinking, what's a micro-credential? Micro-credentials are designed for the business person who doesn't have a lot of time. They basically have lunch hour. And since when was lunch an hour, right? Most of us work through lunch, quite frankly. So a micro-credential is something that's pretty quick. We can do it in a couple hours, maybe over several days. And it basically gives us a concept of something that we can learn in that period of time. It's syllabus-based recorded training. If you'd rather just read the syllabus, you can do that. If you'd rather listen to the recording, you can do that. If you'd rather do a combination of both, which I would recommend, even better. Basically, the syllabus has all the information in it. The recording goes through that information and then adds more to it with more practicality, things that we could do, things that we've seen, that kind of a thing. Within the recorded micro-credentials, there are sample questions, which get you ready for a 10-question exam. Exam's kind of a heavy word for it. It's really more of a quiz. And basically what that does is it makes sure that you know the information that's been gone through, and that way you are awarded a micro-credential. And that proves that you have learned something. So that's much better than saying, hey, I listened to a webinar and it was really, really good and I learned stuff. Okay, but how do I know that you didn't just play solitaire the whole time you were supposedly listening to the webinar? Did you really learn anything? Putting on my manager hat, I would like to see something kind of prove that you actually did it. And that's why I like to see a micro-credential. Want to put that on your resume? Great. I understand that. I can look at that. I can go, perfect. I see that this person has actually listened through something, they have learned something, and they've taken a little test to make sure they actually learned it. There's also some exercises provided if it makes sense based on the material. So a micro-credential is really a mini course, and that's what it's aimed to be. But it's made to fit in the time we just don't have. Honestly, we just don't have a lot of time. So if you've got a couple hours, great. Micro-credentials are definitely for you. Also, just interestingly, you can see in the bottom right corner of this image the little, whatever it is, little diamond symbol. I used Google Gemini to create the image because it's interesting to use AI for the things that it can do for us. This isn't actually what our micro-credentials look like, but it gives you a good idea. And it's really interesting to kind of play with AI, and you can see how it works as a result of that. I had to prompt it multiple times to get what I wanted out of it. And it came up with the image, but then it had a date on it that was 2024, which was interesting. So I asked to remove the date, and I had to give it the information that I wanted to appear on the certificate, which was kind of interesting to play with. But I highly recommend doing that. Play with it a little bit. Play with ChatGPT. Play with Google Gemini and whatever else is out there, just to kind of see how it works. And you can kind of see, well, it's a rough term, how it thinks. So why get one of these micro-credentials? Well, they're written and presented by industry professionals. So these are done by testers. These are not by theoreticians. It's not something where you go, oh my gosh, I got in way too deep on AI. It's basically done by industry professional testers and tailored to what testers need to know based on practical knowledge. So it's stuff that you need to know and stuff that you can use. So basically, you're learning things that you should be able to apply in the workplace pretty quickly. There's real examples, real applications for how to use it, and you can stack up the micro-credentials to end up with full certifications. So at SQA, we'll be offering a certification in AI, which you can get once you've taken the 4 micro-credentials, taken and passed the 4 micro-credentials. And that's credible for your employer as well. SQA is a recognized organization in the testing world, and it means that you did something more than just picked up a webinar that might or might not have been any good, and you might or might not have actually listened to it. So it's a little more credible for your employer. So let's take a look inside. In these micro-credentials, the first one is the AI Introduction for Testers, and it covers a lot of stuff. It talks about what are machine learning models? How do neural networks work at a very high level? How is the machine learning, how does it occur? What's the workflow to actually train it? How do we train that model? How do machine learning algorithms work? Where do they come from? The things that we need to think about with data. We have a lot of considerations with data that we need to think about. And a little measurement here. Now, when we think of performance as testers, we think in terms of how rapidly we get a response to the user. Functional performance in AI words means how accurate is the data? Is it doing the right thing that we're expecting it to do? So functional performance and accuracy. It's a different kind of a measurement. And then a little bit of talk about generative AI, because generative AI is creating things, whereas regular AI is basically taking information and using what it's learned to predict a response. So you've got predictive AI, generative AI, and they're quite different in their capabilities. So for example, I was talking about using Google Gemini. That's a generative AI. So just to look a little bit under the covers here, what is machine learning? There's basically 3 steps to it. Information is supplied to the machine. It basically takes that, it processes it, it looks for patterns. So it analyzes the patterns and it develops algorithms to deal with those patterns. And then it applies it. It's able to make predictive models, and that helps it make decisions. So if you're thinking about something like predictive text, and I think we've all been the victim of predictive text, when you're texting something and it says, ooh, I know what your next word should be. How about this one? And if you don't watch carefully enough, you think, oh, ouch, that was not what I meant to send. But in most cases, it's pretty right. That's what's happened. It's been fed data to train it. It looks for how the text is related to itself, how the different words go together, what is likely to follow in a certain pattern of information. And then it applies that by giving you the prediction. So that's machine learning. Now there's LLMs and there's SLMs. So LLMs are large language models. SLMs are small language models. So LLMs are trained on massive sets of data, sometimes the internet. So huge amounts of data. Hear about things, how the lights dim when they're training AI, or how it has such an impact on the environment because of all the power that it requires. That's an LLM that's being trained. The training is what really sucks the power. And LLMs can understand and they can generate suitable language. They analyze it, they understand it in machine terms, and from that they can generate what should be coming next. They're very expensive, they're very resource consuming, but they can write new content, they can answer complex questions, they can summarize information. If you've used Google, well, who doesn't, it is now summarizing information from whatever, I'm not sure what it's picking from. Maybe it's first 5 responses that it's gotten to the query, and then it summarizes it for you, which is pretty handy, unless one of those first 5 or so is not very accurate. But wow, it saves a lot of time when you're looking things up. So that's an example of AI summarizing information. But Google's done a whole lot of training to get that so that it can be a relatively fast response to your query. SLMs, so small language models, they're smaller, they're less complex, and generally they're targeted. So they're targeted to a specific profession, a specific set of data. So maybe you've got one that's targeted on mathematics and says, you know what, you need to know everything there is to know about mathematics because I'm going to ask you math questions. Oh, okay. So that could be a targeted SLM. Whereas an LLM is, I could ask you anything about anything and I expect you to answer. So big difference there. SLM suitable for specific tasks and specific domains. And that's where the training has been focused. They're less expensive to build, obviously, because they don't require so much training, but they're less capable. They're made to concentrate in this particular area. Pros and cons, right? But when you think about it, the LLMs, of course, are going to be the most flexible, but they're also going to be the most expensive. Now, just a quickie here about neural networks, and this is a lovely picture of a neural network. Neural networks are set up with the input layer on the left side. So we've got data coming in, that's what those arrows are. We've got an input layer, and that's all of the accepting of the data. Then it's processed through the hidden layers, and then there's an output layer that presents it out to the user. So it could be, for example, something that's going to process ChatGPT thing. The output layer is going to be in a form that ChatGPT can give back. So that's the basis of a neural network. A deep neural network has more layers. So the more hidden layers it's got, the deeper it is. Basically, we've got those three major components in a neural network. So the way this neural network works is that each one of these little circles is a neuron. Neurons get information from the previous layer. A layer is one of these columns of neurons. And then they process that information, and they pass it on to the next layer with an activation value. The activation value then is picked up by the next layer, who says, is this something interesting to me or not? And he processes it and sends it on to the next layer. And this is done with a combination of using weights and biases with each neuron to determine how interested he is, what kind of processing he's going to do, and how he's going to pass it to the next layer. So that's at a very, very high level how a neural network works. You notice the communication is between the layers. It's not between the neurons within a layer. It's between the neurons in one layer to all the neurons in the next layer to all the neurons in the next layer. So that's how the communication flows in a neural network. So how do we test that? Well, we could focus on the individual neurons. And in that case, you're looking at, was each one activated? Meaning, did the data activate each one of these? And if not, why not? Was the data insufficient, or is this neuron not needed? And then did each return a value within the expected range? So there's a range of expected values. Did we get the right one? And then can each neuron return a positive, meaning he's very interested in it, or a negative, he's not interested at all in it, activation value? If we wanted to test at the neuron level, that's what we would need to look at. But honestly, that's really white box testing. And that's done by the developers of the neural network. That's part of developing the network, training the network, making sure that it's performing correctly. Now, from our standpoint, as test analysts, we test that the outputs match the expectations based on the inputs. So more black box, really. Unless we're really going to crawl in there and really understand that neural network and how it's working and all the weights and biases and all that kind of information, we're basically black box testing the neural network, giving it inputs, seeing what it comes out with. So that should put your mind at ease a little bit that, yeah, neural networks are there, they are happening, there's a lot going on in there, but on the other hand, we really need to know the guts of it? Probably not, honestly. Unless you're a white box tester, in which case you're probably also developing neural networks, and you're probably already bored with this webinar. For black box testers, still going to be the same. There's inputs, there's outputs. Do they match what we expected? Now, one of the most important parts of any AI development is the data. So there's 3 sets of data that have to be used, and they could be multiple sets of each. There's the training data, and that's what's used to train the neural network. It's what it learns from. Then there's evaluation data that's sent in after the network is trained to say, are you processing it correctly? Have you been trained adequately? That evaluation data is known data, known responses, and that's fed through to see if it's processing it correctly based on how it was trained. And this is where you find things like, oh man, there was a bunch of bias in the training data, and we only gave it medical information on women, and we didn't give it any medical information on men, and now we're asking it to evaluate both, and it can't do it. So the evaluation data and the training data don't want to use the same data, because one of the things you're doing with the evaluation data is evaluating how good the training data was. So we want to make sure that those are separate sets. And then not shown on this picture is a third set of data, which is the testing data. And that's what we use. So again, another separate set of data to see if it's working correctly. So after the training and the evaluation have been done and the tuning that happens in between, then we do the testing to see if it's actually working correctly. So 3 sets of data, critically important that we have 3 sets. So that's kind of the guts of an AI system. What do we test in an AI-based system? Well, the important things here: risk, understanding risk, identifying risk, managing risk, worrying about data privacy and security, because data privacy is a big problem because you don't know where the data is coming from necessarily, especially if we've bought or we're using something that's been pre-trained. We don't know what data it was trained on, and we don't know what data it is cleverly stored in there as information that it should use. We could be accidentally using information that we shouldn't be using. Now, conversely, if we're training it and we're using, say, customer information, which we would do, and we would use that internally, we better make sure that we keep that internal, because if this is something that's a shared system that we're using, we've just trained it on data that is proprietary or private for our company, and now it's available to everybody. So we really have to be concerned about data privacy and obviously security. There's a lot of ways to hack an AI system that are a little bit different than what we think of as normal hacking. And the quality characteristics, those are different for AI systems. So things to think about with risk. There's hallucinations, which is my personal favorite, where it just basically makes stuff up. You think, well, that's interesting, but now and then it'll just make something up. That's a hallucination. And if you play around a bit with ChatGPT, the one that I was using, the Google Gemini, I had it make a chart. In fact, it's in one of the micro-credentials, and it just put some made-up words on there. You think, well, that's fascinating. Those have nothing to do with anything, nothing that I prompted it with, nothing about the context of the image it was generating. It just put stuff on there. That's a hallucination. Reasoning errors are where it's drawing the wrong conclusion from the information. Perhaps it was trained incorrectly, probably was trained incorrectly, or perhaps the prompt wasn't clear, but it's not giving us the conclusion that we're expecting. Bias can occur for several reasons. One is that it was trained incorrectly, and therefore it's biased towards a certain type of data or a certain preference. Or the algorithm's not right, and it's the decisions that it's make are somehow biased. So we always have to watch for bias to make sure that it is giving us what it should based on the information that it's been handed, rather than influencing that decision somehow by some sort of an internal bias. And an easy example of this, which I used earlier, was if we're looking at medical information and we trained it on data only for women, and now we're expecting it to respond to symptoms from men, it's going to have a bias. It's going to have a bias towards problems that women's bodies have, not that men's bodies have. And as a result, it's going to give somewhat biased answers. And that's because the training data is insufficient. And then the other things we always have to test for: data privacy, which is, are we using the data correctly? How is it being stored? Is there a chance that it can get into the hands of someone who shouldn't have it? And then security. And security goes back to the old, you got to know what you're doing to test security. And this is where the experts need to come in to do good security testing. One of the ways that AI systems can be hacked is with what's called data poisoning, when they're fed a bunch of inaccurate or incorrect data or biased data. And as a result of that, it starts giving you answers that are not correct. That is actually a form of hacking that can occur as a security vulnerability. So, different risks that we need to think about. Now remember, an AI-based system doesn't exist alone. It's usually surrounded by what we would think of as traditional software. So we still have all those things to test as well. It's just that we have some new ones now. The quality characteristics for an AI system are definitely different. So we need to look at flexibility and adaptability. How much can the system change? Is it supposed to change? Can it adapt to new data? Can it adapt to new environments? Now, one of the very, very complicated things about testing AI is that it's not going to give us consistent answers. It's going to change, and it's particularly going to change over time because it is continuously learning. So it has to be able to adapt to the information, it has to learn, but it also has to stay correct. So it's a bit of a tricky one there to make sure that it is flexible, it is adaptable, but it's right. Autonomy. Does the system know how to work on its own? Does it also know when to allow to be interrupted? And does it also know when to ask to be interrupted because it doesn't know what to do? If you think of autonomous cars, which are not really autonomous fully, but it needs to know when to hand over to the driver. It also needs to know how to work with the driver if the driver decides to interrupt it. So those are autonomy things. Evolution, can it change? Can it evolve? Can it stay correct? We have to look at the biases, as we discussed. Ethics is a bit of a different quality characteristic. Is it working ethically as society requires? Side effects and reward hacking. Are there ways to get around the intended use of the system? And the usual example for reward hacking is given an AI system to play a game and tell it its goal is to get the highest score. And what it does is it goes in and it modifies the database and it gives itself the highest score. And you go, effective, but it hacked the reward, right? It didn't really play fair. Side effects are things that it does that we didn't expect it to do, or things that it's still working correctly, but it's also doing something else. So is that an acceptable side effect or not? Transparency, interpretability, and explainability are the amount that we can understand what it's doing and why it's doing it. Is it transparent? Can we interpret it? And is it explainable? And these are things that we obviously need to have to be able to test it, because otherwise we don't know why it's doing what it's doing. And it makes it very difficult to test if we don't understand the basis of the decisions it's making. And safety, because some of these systems are running all kinds of stuff, right? Are they going to be safe? Think of the autonomous car. Is it going to be safe? Does it know when to stop? Does it know when to do the things that it needs to do? So safety would be very much tuned to the application of the AI system. But you can see our quality characteristics a bit different than what we're used to. It's not just the old usability, performance, those things. It's a whole bunch of new exciting things for us to learn. Now, our third one is how to test an AI-based system. So we'll talk about the test levels. Are they still applicable? Do we still have unit testing, integration testing, system testing? What testing techniques work? What testing challenges are we going to have? How do we know it's right? What's the test oracle that we can use? Where do we get the acceptance criteria? Again, how do we know it's right? And then how do we handle test environments? Because obviously these are going to be quite important to us, but we've got a model that's learning as we test it. So do we need to be able to reset it back to, okay, forget all that stuff you learned, let's try it again? Or do we need to always just deal with this evolving system that's learning as it goes? Our testing techniques, some of those, adversarial attacks, okay, used to those. Doing bad things to it. Data poisoning, as I mentioned, going in there, purposely feeding it bad information, bad training data so that it starts making the wrong decisions. Pairwise testing, yes, because there are so many combinations of things. Pairwise is really good for cutting down on how many combinatorials we need to test. Now, back-to-back testing and A and B testing are similar, actually. So back-to-back testing is conducted to see if the system under test gives the same outputs as another system that's been developed independently. So basically that becomes the pseudo-oracle, that new system that's been developed. Do the two give the same responses? So this is sometimes done with a legacy system and the new system to see if they're giving the same responses. Because obviously developing two completely different systems, it's really not going to do that unless you're in some kind of a safety critical environment. A and B testing is to see that the results from a new version of the system is the same as the results or compatible with the results of the previous version of the system. So, for example, when you have a new release, you're testing it to make sure that the results are going to be the same as the old system would give, or at least something similar or something acceptable, or hopefully something better. Not obviously exactly the same. If they're exactly the same, then why did you make that new version? Metamorphic testing uses the relationship between the input and the expected output, and that helps determine what the acceptable output is. And that's explained more thoroughly in the microcredential. And then experience-based testing, we all know what that is, and still need it, because we're still doing a fair amount of work with things like error guessing, exploratory, checklist testing, all of those experience-based techniques, because we have a lot to test. And it's easier and some faster in some cases to go in knowledgeably and say, okay, well, let me go after the things that I'm pretty sure are going to break. Let me do those first. So good old experience-based testing is still very applicable to what we're doing. Testing challenges for AI-based systems. So many challenges. So we have the usual things, but we also have autonomous AI-based systems. Sometimes we can't break in and get to the part that we need to get to test. All AI systems are non-deterministic, which means they don't have a single right answer. And I think that's one of the tricky things here. Because if it had a single right answer, then it would be a traditional system, and then we'd be able to test it because we have a known output. We don't. We have to have a range of, okay, that's acceptable. Think about the predictive text. There isn't one right answer. Now, in your head, you may be thinking, well, that's the word I want to use. But it might give you 5 words, and 2 of those are suitable, and the other 3 are, reasonable assumptions. So it's non-deterministic. It's not like it's always going to give you the one right answer. And that's the second problem for us as testers. Just because it gave us that answer once doesn't mean it's going to give us that answer the next time we ask exactly the same question, because it's learned, it's changed, it's got randomization in it, so that it's going to give you potentially a different answer, maybe just as right, but it's not going to be exactly the same. So it's a non-deterministic system. And I think that's where a lot of the complexity comes in our testing. And that is certainly where a lot of the complexity comes in test automation. So we have these complex systems. They're not necessarily just, as I mentioned, just the AI-based system. They may be working with a bunch of traditional systems, or to make our lives even more exciting, it might be multiple AI-based systems working together, all of them non-deterministic. So now we're getting inputs that we can't predict and outputs that we can't predict, and we've got to figure out if they're right or not. You know what? We're never going to run out of work, are we? And then testing for transparency, interpretability, and explainability. Ooh, bit of a judgment call there, isn't it? So what is transparent? What is interpretable? What is explainable? And a lot of that's negotiating back and forth with the development team of how did they do it? Why did they do it that way? Understanding what it is and making sure that it is, if you can't explain why it did what it did, then how do you know if it was right or not? Got some real challenges coming up there. Using AI to test, our last micro-credential. And this one's all about how we can use AI. What is AI-driven testing? How can we use it to generate test cases for us and manage tests and track trends, for example? How can we use it to generate automation, to execute, and then to also implement self-healing? How can we hook it in with the development pipeline so that we know that if they've changed that part of the code, then we need to change that part of the automation? How can we hook those together to save us all a heck of a lot of time? And how can we use it for defect prediction and analysis? Ooh, this part changed, therefore this part's probably going to break. How can we analyze our defects? How do we know which areas of the software are solid and less solid? How can we target our testing better? So we can use AI for a lot of these things to make our testing smarter, faster, and I think more accurate. But remember, AI is not perfect. So we were always going to have to be monitoring to make sure that what we got is what we were expecting to get and that it is accurate. And that's no different than running your queries to do your defect reports. And you have to look at it and go, ooh, actually, that's not right. I've got to fix my SQL. So we still have to look at it. It's not like it's come in to be our fairy godmother and it's going to wave its magic wand and suddenly everything's going to be perfect. Not going to happen, but we can use it for an awful lot. It can save us a lot of time. It's just a matter of using this in an intelligent way to make sure that what we're getting is really what we need. So things like developing our test cases, managing our test cases, creating our automation and our self-healing tests. I like predicting defects. I think that would be really handy because we do this all the time in our heads, right? We say, I know, Bob just released the code. He always breaks the reports. I'm going to look at the reports first. But it would be really nice if it can look over all the defects that have been reported, could look back traditionally how long, it could be back years, across all the developers and the kind of defects that they introduce, and be able to tell us pretty accurately how many defects we should be finding. Now, what this will help us do is predict when are we going to be ready to go. So it'd be pretty nice to have some good predictive analysis in there. I think that would be very, very handy. And obviously it can do some of our defect reporting and our trend analysis as well. So I think the world of test reporting is going to be massively better with AI. I think we're able to crunch through the numbers a lot faster and give us the trends and give us the areas to focus in. And I think that's going to be very, very helpful for us. A lot of potential here. A lot of potential to get rid of stuff that we just don't like to do, like writing test cases. Being able to develop test cases with AI would be really handy. However, it's got to have something to build that test case from. So we're still going to need good requirements. we're still going to need information that we can use to go ahead and build those test cases. Again, it's not magic, right? It's not going to fix everything. It's not going to go out and actually talk to all the business users and find out what they need. It's not going to do that. You're still going to have a business analyst. But it is going to be able to take good requirements and make those into test cases. Sweet. Be able to track them, be able to prioritize them based on risk. Ooh. So it's got a lot of capability here that's really going to help us. But got to learn the new tools, got to learn the new toys, and I think we've got a brilliant future ahead of us. So we're still required. Good requirements are still needed. Human judgment is definitely going to be needed. So AI is a tool. It's not the do-all and end-all. They definitely still need us to get stuff done. But in the end, hopefully we can do this stuff faster. We can get rid of a lot of the mundane work that's not that interesting. If anybody's done maintaining test automation, it can just be mind-numbing work because every release something breaks. Every time it breaks. Just think of having that self-healing test automation work and say, oh, okay, well, this has changed and they changed this object identifier. Therefore, I can just update that and on we go. Oh, wonderful. A lot of good capabilities coming. But it is a tool. We're still needed as testers. We're still needed to bring that independent thought. And we're still needed to prioritize and understand what's being tested and how it's being tested. It's definitely a disruptor. So it significantly changes what we test, how we test, certainly, the expectations for testing. And I think this is going to be an area that's going to be challenging for us because, as a lot of you know already, the expectation is, well, the code will just work, won't it? What's even worse with AI, the code will just magically work, won't it? Getting an understanding of what needs to be tested, how it needs to be tested, and that testing takes time and it takes effort is going to be a new education for the industry. So setting those expectations for testing, understanding or building the understanding in a project team of what needs to be tested and how long it's going to take is going to be a bit different for everyone to understand. Our knowledge is still needed, no question about it. But AI is going to disrupt the way that we have traditionally done things. And maybe that's good, because in a lot of ways I think it could really be an improvement for us. And one thing I wanted to add here, there are 2 ISTQB certifications available now. There's one called Testing with Generative AI, and there's one just called AI Testing. Now, these are full certifications from the ISTQB. Those are different. Those are both substantially large syllabi. Good, I think, in my opinion, quite good. Good information in there, but they are not the same as these micro-credentials. So for the micro-credentials, those syllabi were a basis. In fact, you'll see them referenced multiple times in there. But the micro-credentials are designed to introduce the concepts. It's not a replacement for those full certifications. My recommendation is that you do the micro-credentials first, kind of get the terminology and the concepts under your belt, then go and review the ISTQB syllabi, read those through, and then if you decide to go ahead and take the full certification from ISTQB, then use these micro-credentials to help you with the exam prep for the ISTQB certifications. You're not going to go through the micro-credentials and go, sweet, I'm going to go sit the ISTQB exams. No. There's not enough information in the micro-credentials. They're short. They're designed to be quick, bite-sized pieces of information so that you can understand the concepts. But the ISTQB syllabi go into a lot more depth and into some areas that aren't covered by the micro-credentials. So it's definitely not an exchange between the two. But the micro-credentials, going through those, understanding the terminology, that will help you quite a bit with exam preparation for the ISTQB certifications. And if you decide micro-credentials are good enough, great. Then you've already got that. Go through the 4, get those, get the stacked credential. That may be all you need for work. Or if you want to get the ISTQB certifications, absolutely, go forward with those. You can use these micro-credentials to get you started, get some information under your belt, be ready to go to those meetings and not sound like a fool when they talk about neural networks. But if you want to go on to the full certifications, probably need to do a little additional studying before you take those exams. I think we're all going to need all of this training. There's a lot to absorb, quite frankly, because a lot of it's quite different than things that we're used to doing. For example, like the quality criteria being different, the testing techniques being different. So it takes a bit of time to absorb it as well. So I highly recommend doing both. Do the full set of micro-credentials and then go to the ISTQB certifications. That'll give you the best background of information. But if you've only got time to do the So what's next for you? SQA has a whole library of micro-credentials on interesting topics like APIs, testing, test automation. There's a bunch of them out there. Good idea to look through that library to see what else is interesting to you. New items get added, so that it's a continuous learning environment. And what we're trying to do is make sure that we are on top of the topics that everybody needs to know in their job today so that they can advance and they can have a good career in testing. And that's really the whole idea here, is to keep continuous learning so that we can all stay current, so that we can all stay employed, and so we can have a good career. And that's it for me. Thank you very much. Hopefully you'll go forward and do those micro-credentials. I hope you enjoy them. I hope you find them useful. Do all 4 and get the stacked credential. Thank you very much.